Hello guys, last lecture we studied about classification of polymers. Today we are going to study about some important polymers which are used in our day-to-day life. Before that there are few definitions. So first is homopolymers. The polymer which have only one type of repeating unit are called homopolymers. Example polyethylene, polypropylene, nylon 6, polyacrylonitrile, etc. So these are having only one monomer unit. For example, polyethylene is having ethene as a monomer unit. Polypropylene is having propene as a monomer unit, like that. So those kinds of polymers are known as homopolymers. Next is copolymer. The polymer which have two or more types of repeating units are called copolymer. For example, Buna N, Buna S, etc. Okay, terylene is also there in copolymers. Then nylon 6, 6 is also there in copolymers. So these are made up of two or more monomer units. Two or more different monomer units are used for preparation of copolymers. For example, in Buna S, 1,3-butadiene and styrene are used as monomers. So that's the copolymer. Then next we are going to study some important polymer. First is polyethylene. So polyethylene monomer used is ethene, and it is of two types. Two types of polyethylene are there, LDP and HDP. Low density polyethylene and high density polyethylene. See the preparation: CH2 double bond CH2, traces of oxygen peroxide at 350 to 370 Kelvin, 1000 to 2000 atmospheric pressure. And then instead of this double bond, you have to remove that double bond and place single bond over there, and you have to give bracket and bonds to that bracket, and you will write this N over here. So that's how we can draw the structure of polymer. So this is polyethylene. Structure of low and high density polyethylene are same, means in reactions. Okay. Then next, high density polyethylene, the conditions are different: 333 Kelvin to 343 Kelvin, and 6 to 7 atmosphere catalyst is also used in this reaction, and product is same. Okay, but their compositions are different, linkings are different in LDP and HDP. Let's see uses of LDP first. Low density polyethylene: preparation of pipes for agriculture, irrigation, domestic water line connections, as well as insulation to electric cables. Second use, used in submarine cable insulation. Third, it is used in producing extruded films, sheets, mainly for packaging and household uses, like in preparation of squeeze bottles, attractive containers, etc. Uses of HDP, high density polyethylene. First use, manufacture of toys and other household articles like buckets, dustbins, bottles, pipes, etc. Second, it is used to prepare laboratory wares and other objects. Then next kind of polymer, polyethylene is finished. Next polymer is Teflon. Teflon is also called as polytetrafluoroethylene. So this is the structure of Teflon, and its monomer is CF2 double bond CF2, that is tetrafluoroethylene. Instead of two hydrogens in ethene, we have to just replace those hydrogen by fluorine. So it is easy to remember tetrafluoroethylene. And then similarly, double bond is written, so you will write single bond over here and single bond on this and give bracket, and this N you will write over here. So Teflon is used in making non-stick cookware, oil seals, gasket, etc. These are the uses of Teflon. It is used in non-stick utensils like a pan, a dosa maker pan. So in that Teflon is used, Teflon coating. Next is polyacrylonitrile. Polyacrylonitrile, again you can remember the structure of ethene only. Remove one hydrogen of ethene and put CN, cyanide, over there. Polymerization peroxide is used, and again same thing, instead of double bond you will write single, then bracket and N. So polyacrylonitrile is a substitute of wool, and it is used for making Orlon or acrylane. Generally it is used in blankets. Orlon is used in blankets, so there you can use polyacrylonitrile. Next polymer is nylon 6. It is having a functional group of amide, and when many amide combines, polyamide is formed. So nylon 6 is a polyamide. So this is the monomer of nylon 6. It is called as epsilon caprolactam. So you can see a amide functional group C double bond O NH. So C double bond O NH is amide, and epsilon caprolactam. So 1 2 3 4 5. So when there is a one carbon atom in a cycle, it is called alpha. When there are two carbon atoms, it is known as beta. When there are three carbon atoms, it is known as gamma. Four carbon atoms, it is known as delta. And for five carbon atoms, epsilon is there. So total 5 CH2 are there. Therefore, epsilon is written over here. And lactam is for cyclic amide. Lactam is used for cyclic amide. So epsilon caprolactam. And water 533 to 543 Kelvin, and we are getting nylon 6 as the polymer. Okay, so NH 5, then CO, and then bracket and N. So that's how nylon 6 is obtained from epsilon caprolactam. The name nylon 6 is given on the basis of 6 carbon atoms present in the monomer unit. So you can count here, total 6 carbon atoms are present along with C double bond O, and that's why the name of this is nylon 6. So that 6 is given for 6 carbon atoms. Uses: it is used in tire cords, fabrics, ropes. So these are the uses. It is used in tire cords, fabrics and ropes. Next is nylon 6,6. It is again a polyamide, but in this case two monomers are used. Two monomers used for the preparation of nylon 6,6, namely adipic acid and hexamethylene diamine. So this is one monomer adipic acid, this is one more monomer hexamethylene diamine. They combine OH of carboxylic acid and H of NH2. Water will go out and this linkage will obtain. Okay, so this O minus, then CH2 is as it, CH2 4 is as it is, C double bond O minus, NH3 plus, CH2 6 and NH3 plus. So what they did in this intermediate step, acid are proton donors and bases are proton acceptor. So this H will donate proton because it is acidic, and this H will donate proton to this NH2. So O minus is left and this NH2 will become NH3. Same for this and this. So acids are proton donor, bases are proton acceptor. Based on that concept, this intermediate is written. And then removal of water at 553 Kelvin, that I already told you, OH of this and H of this. So water is removed and ultimately we'll get nylon 6,6 as a polymer. So the numeral 6,6 in the name of this polymer stands for the number of carbon atoms in the two bifunctional monomers. Uses: it is used for making sheets, Bristol for brushes, surgical sutures, textile fabrics, etc. Next polymer is terylene. So terylene is also known as dacron, and it is a polyester. And monomer used are ethylene glycol and terephthalic acid. So ethylene glycol and terephthalic acid are used to prepare terylene. Ethylene glycol is written, terephthalic acid is written. Two COOH groups are at para position, and here ethylene means 2 carbon and glycol 2 OH are on adjacent carbon atoms. So ethylene glycol, terephthalic acid, acid plus alcohol. Acid plus alcohol always give ester. So this is the ester linkage, and many ester linkages are there, therefore it is known as polyester. Water molecule is removed, H of alcohol and OH of carboxylic acid, so that's how water molecule is removed. Condition 420 to 460 Kelvin. Zinc acetate antimony trioxide catalyst is used, and ultimately we are getting terylene. It is also called as dacron, and it is a polyester. Ester linkage is there. Let's see the uses. It is used for making wrinkle free fabrics by blending with cotton, that is terracotta, and wool, terry wool. So that's its use. So no need to iron this, we can directly use these fabrics. Second, it is used for making many articles like bottles, packaging containers, etc. So that's all for this video. Thanks for watching the video. In next video we are going to study about remaining polymers and their uses.